by varying x, f prime of x defines a function called the derivative of f with respect to x. And so what's the definition of f prime? The limit as h goes to 0 of f of x plus h minus f of x all over h. The function f is differentiable at x means that the limit exists. Okay. So we're going to use, you should be very good at this point at finding the derivative using the definition of derivative. So you want to try this?
Yeah, ours is all messed up.
Oh. So what I would do first is find f of x plus h. So that is 2x plus h squared plus 3x plus h plus 1. So if I FOIL this, I get x squared plus 2xh plus h squared. So if I multiply that by 2, I get 2x squared plus 4xh plus 2h squared plus 3x plus 3h plus 1. Can I combine anything there? Oh my gosh, I don't think I can combine anything. But when I get it into the limit, so f prime of x is equal to the limit as h goes to 0 of that big conglomerate and then subtract. You guys, when I subtract this, can I just switch all these signs so that I don't have to write it again? So 2x squared minus 3x minus 1 all over h. So now I can cancel some things. Cancel, 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 cancel. Everybody good with that? And so anything that's left on top has an h on it. So in the next step, I'm going to factor out the h at the same time. Is everybody good with that? I haven't actually done the limit, so I still have to write it. So this is 4x plus 2h plus 3 all over h. The h's will now cancel. I'm now going to put 0 in for h, and what do I get? 4x plus 3 as my final answer. Is everybody good with that? Okay, because we can think of the derivative at a point in graphical terms as, what's the derivative again? Slope. We can get a good idea of what the graph of the function f prime looks like by estimating the slopes at various points along the graph of f. So here is the graph of f, and we need to graph what f prime would look like. And this is actually something that's pretty hard at first for some people, but if you understand what you're looking for, it actually gets quite easy. So what we're going to graph here is this is now going to become f prime, and this is our x. So at 0, 0, remember, we're not graphing 0, 0 anymore. The x is changing this, the x is staying the same, but our y value is now what the slope is. So again, what would this, say be? Right at 0, like what would that, approximately what kind of slope would that be? It's positive, definitely positive. Approximately what? Looks like a slope of 1? 2?
1.5.
But you guys are looking at this whole thing here. Just look right there. Like, is that like an up? Like, there's no value here. Is it like an up 1 over 1 kind of thing? It's approximately at 1. So now I'm going to put 1 there and say, okay, that's where I'm starting at 0, 0. Now, when I get to, say, about here, is that less steep or more steep than where I started? Less. So that means, so if I just take, there, 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 and there, just to break it up here. So at that point there, it's a little less steep. Let's do approximate 0.75. Okay. Okay, so that'll be this point. I'm going to put, say, there. Yes? Okay. So then right here, what's the slope of that? Does everybody see it's 0? At that point right there, it's 0. It's a, yep. So that means it'll be right there. Yes? Okay, so then this one right here, what's that? It's pretty much the same slope as that, except this time it's negative. So if I put a -1 here, at that point, let's use Kyle's logic. It was what? 0.75, but now this time it's negative. Yeah? And then right here, what's that? So it's a 1, but it's going down to the right, so it's a -1. So there it is. Does everybody see it's kind of looking like this? Yeah? Okay. So now I'm going to break this up again. So what about at that point right there? What's that slope? It's a little bit less shallow, right? So it's maybe going back. It's still negative, but it's. We said this was -1. Now this is less shallow. So if we use the logic of 0.75 again, and then what's this right here? 0. And then after 0, what's this? 0.75 again. Say about there. And then right where we end, what would that be? At 1? Sure. Hey, you graphed your first... Oh my gosh, I just heard that. It looks like a sine graph and a cosine graph. Guess what one of the rules later becomes? The derivative of sine is cosine. Yeah. Now, I don't know for sure because I didn't have any values if that really was sine and cosine, but I would agree it definitely looks like that. Okay, let's try this again. You like this? Kind of fun, hey? Okay. F prime. I think actually the hardest thing is going backwards, but anyways, so now, what's this? 0. So does everybody agree it starts at 0? You agree. Okay. So then let's just break this up again how we did. So like say there, what's that slope? But it's negative though, right? It's negative right there. So that's say there, about 0.75 or whatever. Okay, and then right here, that would be a -1. So it looks like it's going like that. Then at right there, it's going back up. It looks like it's just less slope, right? And then here it is 0. Yes? And then now, look at this slope now. It is a positive slope. So if I put 1 there, the positive slope, if we use, rough terms, 0.75, yeah? And then, where am I? So that was there. What about right there? That looks like it's about 1. So I'm going to go here. And then halfway right there, it's coming back down. Would you agree? And then when it goes there, it's back to 0. Does everybody see it? It ends at 0? Okay, the next one is pretty interesting, actually. The next one is kind of interesting. And does anybody think, you know why I'm saying the next one's pretty interesting? I'm sorry, what? It is the same slope, the entire part of this.
So it's just straight line.
And then this is the same slope, but it's the opposite sign.
Straight line down the straight line.
So question for you, what happens at this corner right here? It's a jump. Very good. You can't actually figure out what the tangent is there. So, wow. Okay, so now that you know that, can you just try it and see if you can get it? You'll probably get it wrong. Well, then do it in pencil. Do it in pencil. And what slope do you think this is approximately, by the way?
-1.
A -1 slope and a +1 slope. Okay. So did you get something like this? And then something like this?
So an absolute.
And so now you have to have a hole there because there's no slope at that one point. It's not differentiable at that point. So for instance, we could say this is point, I don't know, A. So this is point A here, right? Just so you have a reference of where. Was there another question? No, you can't actually find the slope of a corner because you don't know exactly where you would put your the angle of the pencil. So, all right. One-sided derivatives. The derivative is a limit. These limits must be defined from the left and the right except at an endpoint if the domain is a closed interval. In piecewise functions, the derivative limit at a given point, some a value, must be equal from the right and the left for the derivative to exist. So essentially what I'm doing is I'm giving the definition of a function being differentiable. So the function f of x is differentiable on a closed interval a, b, if the derivative at any interior point, interior of a and b, and the limit on the right and the left exist. So does everybody see? You basically just have to know that these have to exist in order for this to exist. At any interior point, they have to be the same, right? So going back to this one, does everybody see coming to this point right here? This is a negative, coming from the left at point, say, A. This is a negative slope. I approximated it at -1. This is a positive slope, so the derivative doesn't exist right here. Does that make sense to you based on this definition I just gave you? Okay. So here's the next one here. Show that the following function has left-hand and right-hand derivatives at x equals 0, but no derivative there. So we're going to find the left-hand limit at 0 and the right-hand limit at 0, and then if they don't equal each other, then we know that the limit doesn't exist at 0. So the limit as x goes to 0 from the right, which function would I use? Which function would I use? 2x. So now if I plug in 0 into that, what do I get? I get 0. So the problem here is if you look at this definition here, is I wasn't actually finding the limit as a goes to 0. I was doing the definition of derivative. So does everybody see what the difference, what I just did there? I was just finding the limit and seeing if it's continuous. So I'll repeat that. Remember from the last unit, if I find the left-hand limit and the right-hand limit, and then the function value is the same, then that just proves it's continuous, which I can see at this graph it is continuous, like I don't lift my pencil. What I'm trying to do here, though, is I need to find the left-hand, the right-hand derivatives. That's not the derivative of that. So what do I have to do? I need to plug it into that formula, yeah. So I need to find the derivative first off. So how do I find the derivative? Yep. Essentially, it's what this definition just told you right here, right? Yeah? So because this is at a particular point, I like the questions here. So when you did your homework, you didn't know, some people are still confused of which formula to use. So if it's a general formula, then you would use the x plus h, blah, blah, blah. But because I'm only testing 0, I can use the derivative at a certain point, which that definition is the limit as x goes to a of f of a minus f of x over, sorry, I'm doing it the wrong way. I apologize. F of x minus f of a over x minus a. Do you remember that? Okay.
It's like for switching 0, it doesn't matter. This is 0.
Yeah, so the x is going to go to 0 here. So we're going to do the limit as x goes to 0 from the right first. So f of x would be then 2x, yes? And f of 0 is 0, so subtract 0 over x minus 0. So what do I get here? 2x over x as the limit x goes to 0. The x's will cancel because otherwise it'll get 0 over 0, right? And what do I get? 2. So let's look at that for a second. Is this line right there on the right of 0, is that approximately a slope of 2? Yeah, look, if I measure that, it's pretty noticeable that that slope is 2. Do you see? So coming from the right, the slope is 2. So now we need to come from the left. Yes? So f of x would now be x squared. So that would be x squared minus f of a would be 0 over x minus 0. So what do we get there? We get x squared, sorry, I should be putting the limit. The limit as x goes to 0 from the left of x squared over x. If I plug it in just like that, I get 0 over 0. That doesn't work. But I can simplify this because one of these x's will cancel one of these x's. And so what does my limit equal then? Well, the limit, but then when I evaluate the 0 in there, what do I get? 0. So do you see? And let's look from the left. This is a parabola, but when on the left is 0, does it look like it's approximately 0 there? Like it's pretty much coming to a min there, right?
Again, the rest of the function exists. So
therefore, the left-hand derivative doesn't equal the right-hand derivative and the derivative does not exist at x equals 0 then. The left-hand derivative doesn't equal the right-hand derivative, so the derivative doesn't exist then. Okay. So the next one's kind of fun. You need to sketch, and they get you to do this on the AP exam. You need to sketch using these properties. So could you sketch this given the following properties? F of 0 is defined and it's 0. F of x is continuous over all the reals. And the derivative is equal to -1 when x is less than 1, and it's equal to 2 when x is greater than 1. Yeah, so basically I'm telling you the slope there. So I'll give you a second to see if you can draw that. So notice it doesn't have a derivative when x is, it doesn't have a derivative when x is 1, but it does say it's continuous over the reals. So does that mean I have to have an open circle or a closed circle at 1?
Half colored, half not.
Open circle or closed circle? Again, it doesn't have a derivative at 1, but it says it's continuous over the real. So does that mean it would be closed? But how do I make a closed circle not have a derivative? Well, okay, so here is y, here's x. First off, this has to be there at 0, 0. Does everybody get that? So I'm going to do some scale to this. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so then it's saying at 1, on the left of 1, it has to have a slope of -1. So here's 1. How would I have a slope of -1? So if this is a point here, where is it going to say here? Or here? Where is it? It's here? No, it's here? Yeah? Because it has to be a slope of 1 negative, right? So it has to be a diagonal line going like this. Yes? And when it gets to 1, it would be at -1. And then on the right of it, it has to be a slope of 2. So at this point, I have to go up 2 over 1. Up 2 over 1. So then it goes straight like that, right? So this is the slope is -1. This is the slope is -2. Right there, there is no slope because it's a corner. Anytime you have a corner, you have no slope because